What is up, Flutter devs? Welcome to today's Widget Workshop. A Widget Workshop is a relatively brief live coding exercise where I show you how to build a particular widget or visual effect in Flutter. They typically range from 20 minutes to an hour, depending on what we're building. Today, we're building a color picker widget that allows us to pick between 5 different colors for a paint product. This design comes from Dribbble, and a link is available in the video description. This particular workshop went overtime, so we'll build something very close to the goal design during the workshop. But if you want to watch the full details of building the color picker, you'll have an opportunity to purchase that extended widget workshop on my website at superdeclarative.com. As always, I'm trying to build a large Flutter education community here on YouTube. If you enjoy these videos, please be sure to like, subscribe, and to share. Now, with that said, let's get into the workshop. All right, let's get started with today's widget workshop. On the screen here, you can see a couple of things. You can see the design that we're basing our widget on, and you can see over here in this iOS simulator on the right that we have an ugly black box, which conveniently is waiting to be replaced by the widget that we're going to build. So in this design, we want to get this color picker widget into this black box. So let's get started. Now right here is a widget that draws that black box. If we replace this widget, or if we implement this widget with what we want, then we're done. That's our goal for today. So I would like to suggest to you that our creation of this color picker really comes down to fulfilling 3 goals, 3 independent goals. Step 1, render a color spectrum. Step 2, recognize the color that the user selects. And finally, step 3, make the color spectrum into a pretty shape. And if we accomplish all 3 of those things, then we are all done. So let's start with step 1. Here we have this container, and you can see that its color is black, and that's why we have a black rectangle on the screen. But that rectangle conveniently is exactly the size and location that we want it. So if we can somehow replace that black color with a color spectrum, then we're good to go. So let's see what we can do. We know that we don't want a color because this is a color spectrum, but fortunately for us, Container has something called decoration, which takes in a box decoration, which accepts a gradient. And a gradient allows for a linear gradient, which is defined by a list of colors. So just to give you an example of what we're talking about, let's create a linear gradient from black to white. And let's see what happens. Look at that. Over here in our iOS simulator, on the left we have black, on the right we have white, and everywhere in between we have a bunch of gradient or gradations which are interpolated between the 2 colors. So if we could just get the colors that we want in there, then our problem is solved. Let me very quickly introduce you to a little bit of content that already exists in this project because it's going to be relevant to what we're doing right here. In this watercolors file that I have, I've hard-coded these different products because you don't need to see me write out a bunch of this text. But each of these products, it has its own name, it has its own description, it has its own ID, and most importantly, it has its own color. So this first product is whitish. It's a very, very light gray. The second product is yellow. The third product is red. The fourth product is blue. The fifth product is a very dark gray. It's verging on black. So I've hard-coded all those values. Those are the 5 colors that we want in our color spectrum. So we need the spectrum that we want to draw here needs to go from the white color up here all the way through these other colors down to the black color, which is the last one in the list. Now there's a second concept here that's important to distinguish. Yes, we have a spectrum of colors, but notice that these blobs, they represent the actual selectable colors. Like there's only 5 products. There's an infinite number of colors in here, but there's 5 products. Those 5 products have 5 colors, and those are represented by each blob. Okay? So we need to understand that our spectrum is actually interpolating between just 5 selectable colors. Here in this hard-coded file, I have created the concept of a selectable color, which is nothing more than an ID and a color value put together. But I have this global property called selectable colors, which takes all of those watercolor descriptions you saw above, and it captures each of their colors. It's a way for us to talk about 5 colors without passing our products around everywhere, because most of the UI doesn't care about our watercolor paint. It just cares about what color. So this list right here called selectable colors, it essentially is a list of colors that we need to display in this spectrum. So let's go back to where we were. And in this linear gradient, if we can pass in a list of selectable colors, then we should get the spectrum that we want. So let's see what we can do here. Let's take selectable colors and let's map them. So for every selectable color in that list that I showed you a moment ago, let's return the actual color value. Remember, selectable color has an ID and it has a color. All we care about is the color. And this is going to give us an iterable or a map or something, so we need to coerce it to a list. So theoretically, we have now extracted the 5 colors that we care about, we've put them in a list, and we've sent them to the container. So when we save this, we should see the correct spectrum on the right. So we're going to do that in 3, 2, 1, save. Did it work? I'm looking at you. I can't see it. Did it work? Is it there? It's there. We got it. We got the rainbow. So over here, we can see that we have white to yellow to red to blue to black. These are our selectable colors spread evenly, starting all the way on the left, going all the way to the right. And though the colors might be a little different than the ones that are in the spec, we've essentially accomplished what we came here to do in step 1. We now have a color spectrum rendered in a rectangle. Of course, before we move on to step 2, as is always the case in software development, this is our opportunity to ask if maybe we should refactor our code. Well, this widget that we're working in, it's the color picker. It's going to contain everything. And yet we have this little widget tree here that seems to represent just the responsibility of rendering a spectrum of colors. So it makes a lot of sense to me that we would actually extract this into its own widget called color spectrum. So I'll come up here, I'll right click on container, and I will say refactor, extract Flutter widget, and I will call it color spectrum. And now our color picker is nothing but a color spectrum, which is good because we're going to add a bunch more stuff to this. But there's one more detail. Because our color spectrum widget references this global selectable colors list, it means that wherever we use it, it's going to have the same colors in it. And that might be okay for this little prototype, but you would never want that in your own app. Who knows where you might want to use this color spectrum widget. So what we're going to do is we're going to take this map right here and we're going to cut it out. And we're just going to pass in a colors property, which doesn't exist yet. It doesn't exist yet, but we're going to make it exist. So we're going to come up here and we're going to say final list of color called colors. And then up here in the color spectrum constructor, we are going to require that whoever is using this color spectrum give us a list of colors. And now up here in our color picker, where we create a color spectrum, we're going to pass in that same list. So let's save it. Everything still seems to be good. Just to be totally sure, we can do a hot restart. Everything still looks good. So we have just solved step number 1. We have solved step number 1. And now what we need to accomplish is step 2 and step 3. We need to somehow figure out when the user presses down and drags, what color is the user selecting. And finally, we need to cut out some pretty little shape that makes it look like a bunch of blobs all strewn together. So let's move on to step 2. All right, time for step 2. We need to recognize the color that the user selects. So it's pretty obvious where we start with this. We're going to need a gesture detector. So we'll wrap with a widget, we'll wrap with a gesture detector, and gesture detector offers us 2 callbacks that will be very useful. On pan down, I think that's, let's see, what was the signature for on pan down? Drag down details. So drag down details is what it gives us. And then there's also on horizontal drag update, which receives a drag update details. In both of these cases, we pretty much just need to take the local position where the user is pressing or dragging and pass it off to a local function, a method that figures out what color the user is then selecting. So let's assume that we have a method called select colors, and we'll pass details local position. So that's the offset, the X and Y value in pixels where the user is currently pressing or dragging. Well, that one is specifically pressing. Horizontal drag update is actually dragging. So now we need to define that method. So we take in a touch position. Now, before we really delve into the details of how to turn that touch position into a color, we need to recognize something about the geometry in this spectrum. If it was nothing but a spectrum, we could kind of go right into looking at color distribution, at linear interpolation, but because we have these blobs, it's actually the center of each blob that represents a color, the center of each blob. And so let me show you what that's going to mean for us in terms of our calculations. Let me just do a little diagram here. Let's say that this is our spectrum. If we want to know the position on our spectrum where one of our 5 colors actually sits, it's the center of the blob, which means where my cursor is right here, assume this is a circular blob, my cursor is radius distance from the left. So the blob has a diameter because it's a circle. If you go radius distance from the left, that's the center of the first color. And the center of the last color is radius distance from the right. So we can't just start at 0 and divide up by 5 or something. That's not going to give us the correct position. We need to take into account these actual blob sizes, which means that we need to actually calculate what our blob sizes are. What's our blob diameter and what is the distance between our blobs? So let's do that. Now this is going to require a render box. A render box actually tells us the pixel size on the screen of the spectrum that we're painting. We're going to need that information, and getting that information is going to require that we convert to a stateful widget. So I do a little option enter, I say convert to stateful widget, and now we're a stateful widget, which then allows me to say this. I can declare a render box, and I can say context.find render object. Now that render object happens to be a render box, and we know that, so we auto cast it into a render box. And the reason we need that, we're going to now make some assumptions. So looking back at this design, I think it's reasonable for us to say that the diameter of a blob is equal to the height of the widget. I think that's a reasonable way for us to derive that value. However tall this widget is, that's the diameter of one of these blobs. So with the render box in hand, we can say final double blob diameter is equal to the height of the render box. And because we'll probably want it for calculations, we can also talk about the blob radius, which is of course equal to the blob diameter divided by 2. That tells us with the blob diameter, we know the width of every one of these blobs in the spectrum. But we also need to know about this distance between the blobs. We'll call it a separator distance. So how do we actually calculate what the separator distance is between the two, or the separator space? Well, again, the render box tells us what size it is. We know the total width. And we also know that we have 5 colors, and we know the width of each blob diameter. So what we can say is the separator space is equal to the total space, so the render box dot size dot width, minus, now we need to know the number of colors. And again, to make this really easy for us to talk about, let's declare color count. And that's equal to selectable colors. Remember, that's our global list of those 5 colors. And we'll ask for the length, so that's 5. And we will say 5 times the blob diameter. So we accumulate all of the blob width and we subtract it from the total width of our spectrum. That gives us the total amount of separator width. But that doesn't give us each individual separator space. It gives us all 4 of these added up into one. So we actually need to divide it. We need to divide it by 4. And what is 4? 4 is the number of selectable colors minus 1. And that's because a blob is at the very end of the spectrum. So the number of spaces that we have is the number of colors minus 1. So let's come over here and let's divide this number by color count minus 1. So we now know the diameter of every blob, the radius of every blob, and the space between every blob. And now we can start figuring out where in this spectrum the user is actually pressing. So let's figure out the touch X position. Now at first you might want to say, oh, that's just the touch position and grabbing the X out of it. And that's true. However, if the user drags far enough to the left or far enough to the right, it will actually exceed zero. It will go below 0 into negative numbers, and it will exceed the greatest width. And that's going to mess with our math. So we want to take this X value and we actually want to clamp it. We want to clamp it 0 on the left, and the maximum value to the right should be the width of our spectrum. So the smallest X position that the user can touch is 0, and the maximum is all the way to the right. Now with that X position, we want to determine a fractional number. So we know as we look through this spectrum, over here on the left is color index 0, and then color index 1, color index 2, color index 3, color index 4. We essentially need to figure out the closest color index to the user's position. And the way that we're going to do that is first, we're going to figure out which color is to the left, which selectable color is to the left. I guess for you, that's actually over here. To the left of the user's finger, and then the color to the right of the user's finger. And once we know those two colors, it's trivial for us to figure out which one's closer. So we're going to create a fractional number. We're going to have the fractional touch position. So this is going to be the X position divided by, we know that we have a repeating pattern of diameter plus space, diameter plus space. So it would make sense that we say blob diameter plus separator space. But that's not quite correct, because we don't begin at the middle of a blob. Or I should say that we have, essentially, if we group these, so we have blob, space, blob, space, blob, space, blob, space, but then we have this one last blob over here. So really, we need to account for kind of a radius on either side. So it's not just the touch position. It needs to be the touch position minus the blob radius. So if we move back a radius amount and then we divide by the blob diameter and separator space, then we're going to get a fractional position. For example, like if we touch right here, we're going to get, I guess, 0.5. That's halfway between 0 and 1. And then right here is 1.5, halfway between 1 and 2. But there's still one little problem here. If we go way to the left, if we're like not even a 1 radius from the left, then this value here is going to be negative. And that's not going to be good. We don't want that. In that case, we really just want 0. So we will take the maximum of the touch X position minus the blob radius and 0. Import math, and that should give us a fractional touch position. Let's go ahead and see what our fractional touch position is. Save that, come over here, tap right here. So I tapped right in the middle, which should be directly above our third color, which is actually index 2. And notice that our fractional touch position is just about 2. I'm just slightly over that position. Now let's drag to the left. Now I'm about halfway between the second and third color, and notice that it gives us 1.5. Keep going down. Now right here, I'm essentially right over the yellow color, and we'll keep going. And notice that it hits 0 before we get all the way to the left. That's what we were going for here. Because we have a blob there. We don't want 0 to begin all the way over here on the left. We want the 0 position to be right in the horizontal center of our first blob. And same thing with our final blob. Come all the way over here to the right. I hit 4 right here, right in the middle of that final blob. And then really we just want it to continue at 4. And so that's it probably wouldn't hurt for us to clamp that. So the fractional touch position, we already took care of going below 0 right here. We can take the entire value. And in fact, let's just handle this. Instead of doing max and min, let's allow it to be negative here. But then let's take the entire value and let's clamp it between 0 and remember 4 is as far as we want to go to the right. That is the color count minus 1. And let's save that. And now again, let's drag all the way to the left. Oh, let's see, it's complaining about an integer. I'm guessing that's this guy right here. Save that. Drag all the way to the left, no matter how far we go. Oops, it does. I guess negative numbers are still a problem. Let's see why that's an issue. So touch X should be clamped at 0. And we know that this might be negative, but we should be clamping it at 0. Let's see. So it's complaining about passing an integer somewhere. I mean, I guess it could be this number. Well, it shouldn't be that number. What would it be complaining about as an integer? So whenever I go beyond the spectrum, either direction, it complains. Maybe this is what it's complaining about. Yeah. Okay. So here's the problem. I guess whenever you use clamp, you need to be really explicit that you're dealing with doubles and not integers. Not sure why it can't do some casting. Maybe I'm missing something, but this should solve our errors. So I drag all the way to the left, and even if I go past the spectrum, it's fine. It says 0. Even if I'm on the left side of the first blob, it says 0. That's what we want. And then once I get past that first blob and start going up, now it correctly accounts for where we are. So remember what this count is telling us. When it's at 0 point something, it means it's between color 0 and color 1. Then 1 point something is between color 1 and color 2. 2 point something is between colors 2 and 3. And then 3 point something is between colors 3 and 4. And then no matter how far I drag to the right, it says 4. Because we have no color beyond 4. There's no color 5. So that's good. We're kind of mapping our spectrum now. And now we need to start figuring out what colors we're really dealing with. So the first thing that I want is the left color index. That means the color to the left of the user's finger. Now, again, let's take an example. Let's say we're at 1.75. What did I just say? That means we're between color 1 and color 2, which means if we take 1.75, now color's at index 1, color at index 2. So if we're at 1.75 and we just lop off the 0.75, that gives us the index of the color on the left side. So the left color index becomes the fractional touch position floor. Floor means it just cuts off the fraction. And then the right color index is the fractional touch position ceiling, which rounds it up. So again, let's save that. Let's go ahead and print all three of these actually. So colors, we will print the left color index, then this arrow, then the fractional value, and then the color on the right. And I'm going to get rid of this print statement here. Okay. So look, between 1 and 2, now between 2 and 3, now between 3 and 4. So we now know what color is to the left and what color is to the right. And now we need to talk a little bit about what it means to select a color. So we're not actually just selecting one color, we're selecting two colors. There's the product color, which is the nearest neighbor thing that we're talking about, the nearest selectable color. We need that one. But we also need the actual interpolated color, because if we look back at the spec, yes, the product is based on which color you're touching, but notice that the background of the UI represents the interpolated color. The background of the UI is whatever exact color you're touching. So we need two colors. So first, let's figure out the selectable color. So the selectable color to the left is clearly just whatever color is at that index, at the left color index. And the selectable color to the right is clearly just the selectable color at the right color index. And then if we want to choose which one is actually selected, if we want the actual selected color, what we're going to say is fractional touch position. Remember, that's like 2.2, 2.4, 2.8. We're going to subtract the left color index. So if the fractional touch position is 2.3 and we subtract the left color index, that's 2.3 minus 2, we get 0.3. We're 30% away from the left color. If we're 50% or less to the left, we want to select the left. If we're over 50% to the right, we want to select the right. So that's why we do this little check against 0.5. And if it's less than or equal to 0.5, we want to select the left color index. Otherwise, we want the right, sorry, not the index, but the actual left color. We want the left color, left selectable color, right selectable color. Let's see, what's it complaining about here? There we go. Okay. So now that is the selected color. That is either color 0, 1, 2, 3, 4, or 5. But it's not the only color that we need. We also need what I call the spectrum color. This is the exact color on that spectrum. Fortunately, the color class actually offers a linear interpolation function. So you give it 2 colors and you give it a percentage in between the colors, and it will give you the color that you want. So this is one of the reasons that we calculated the left color and right color, because we want to interpolate between the two of them. So we want some color between the left color and the right color. And how far between do we want? Well, that is nothing more than our fractional touch position minus the left color index. It's the same thing that we calculated right here. It's essentially the percentage from the left. That's what we want to linearly interpolate. So we now have the selected color and the spectrum color. We could print that out, but the color values aren't going to make a whole lot of sense to us when we see them in hex form. Really, what we want to do is apply them to the UI and actually see the UI do what we expect it to do. So in our color picker here, we need to actually take in a callback. So it's a function. We want someone to give us a function that will take a spectrum color and a selected color. Okay, and we need a constructor here that takes it. So color picker, we will take, I guess we have this dot on color selected, save that. And then up here in our watercolor store, we will pass in on color selected, which is going to receive a spectrum color and is going to receive a selectable color. Or really that's the selected color. And this was already set up before we got here, but notice that this watercolor store, it takes in a background color and a product color. And it's represented by these existing variables. Initially, they're just hard-coded up here to gray for the color and then the initial product. And actually, I've already implemented the function that we're going to re-implement. But the point is these two variables exist, and all we have to do is update them with the new spectrum color and the new selectable color. So we'll call setState, and we will say that the selected watercolor description, let's see, we're going to use a static function that I created, find watercolor description by ID. So selected, I typed it wrong again. This is the selected color. The selected color.id, that will tell us which product to display. And then the store background color is going to be equal to the spectrum color. Now let's go ahead and actually, we still have to invoke that, sorry. So back here in our color picker, we have the two colors. And now we're going to say, if a onColor selected was provided, because we don't know if it was passed in or not, but if it's not null, then we are going to invoke onColor selected, and we're going to pass our spectrum color, and we're going to pass our selected color. Now let's save that. Oh, what's it complaining about? We'll add a semicolon. We will save that. Let's come back here. Let's start selecting on the left. Notice the background color changes and go from there. Now you see that? The background color is whatever the spectrum color is, but the product only changes when we get closer to one of those blobs. We can't see the blobs yet, but we've calculated the location as if they exist. Okay, so hopefully that all made sense. We have now technically completed step 2, but I'm going to introduce a step 2.5, which is clean up color selection code. a little bit of refactoring work here, similar to step 1, but we're going to do a little more refactor here, a little more of a cleanup. So we're going to do that in step 2.5. Here's the primary thing that I don't like about the current code that we've written. We have this color picker widget, and we've essentially implemented a logical understanding of the geometry of this blob spectrum thing. And it's okay to have that inside the widget that draws the spectrum because they're kind of one and the same. But there's nothing that prevents us from taking the logical calculations of this spectrum out of the widget and putting it in a plain old Dart object. And so I think that's what I would like for us to do. Let's come down below this widget and let's define a color blob spectrum. And this isn't going to be a widget. It's not going to render anything. It's going to be the logical representation of that spectrum. And it's going to know how to calculate the selected color and the spectrum color on our behalf so that our widget code doesn't include so many of these weird calculations and values and stuff like that. So in a minute, we'll fill out the normal constructor for a color blob spectrum, but I would like a factory method for this. I would like to create a color blob spectrum based on only 2 pieces of information. The first is a size, both width and height. And the second is a list of selectable colors. And from these 2 pieces of information, we should be able to calculate everything we need to understand where the blobs are, where the space in between is, and where a user actually selects a given color. So we still need to invoke the regular constructor. And essentially the regular constructor is the sum of information we need. So the total information, we will need a blob radius. I mean, you could go diameter, but it's just a derived property. We'll declare a radius, and then let's see, what else do we need? So we're going to need the width. So we will say spectrum width, and then we know that we're going to need this list of selectable colors. So we'll take all of these into the main constructor. Oh, sorry, this is a factory method. So I want to call this from physical dimensions. And then the blob radius is going to be equal to the height divided by 2. And actually, let's go ahead and do diameter. I think diameter is an easier thing to pass in. And what we can do then is we can also declare a blob radius, and I think we can make that a derived value here. So blob radius equals blob diameter divided by 2. So we will say blob diameter is equal to size.height, and then the spectrum width is equal to the available width, and then the selectable colors are the selectable colors. So anyone could construct this using all 3 of these properties explicitly, but we know that in the typical case, we're going to have a render box, so it's going to be really easy to grab the size, and we can infer the blob diameter and the spectrum width from the size. So again, the purpose of this class is to represent a logical understanding of the spectrum. And there are 2 questions that we want to ask of this spectrum. The first is to calculate the selected color given a touch position. The second thing we want to calculate is the calculate spectrum color. Again, given a touch X. So this is the behavior that we implemented before. And what I'm doing here is I'm breaking it into two methods. And what that means is we're actually going to replicate a lot of the same logic between these two methods. But I think from the outside, it's nicer to just be able to say which one you want at a time. I don't think it's a big deal that we're going to run some of the same calculations over again. So coming back up here into our widget where we are currently calculating all this stuff, we know we are receiving blob diameter. We can calculate color count on the fly, which I guess we should do directly. Let's just copy all this stuff and we'll take out anything we don't need. So we'll copy that. First, we'll start by calculating the selected color. So we don't need the spectrum color in here. And since we're returning it, we don't need to set it to a value. We'll just return. And then up here, let's resolve some of these assignments. So blob diameter and blob radius are already defined within our class. Color count is selectable colors.length. That's fine. Then the separator space, this we no longer have a render box. Instead, we have a spectrum width. And then let's see, we're grabbing the touch X. So we're taking the touch position, which we've passed in as touch X. We're still clamping it. That's fine. And then here for the render box width, this is spectrum width, which we no longer need to cast to a double because we stored it as a double. Let's see, where else do we have some red here? Oh, okay. So I already gave it the name touchX, so we have conflicting variable names. For the incoming property, let's just call it position. Actually, I guess let's reverse that because really what's coming in truly is the X position. It's this value that is the local position. So we'll clamp touch X to get the position. Okay, so now we've replicated the behavior to calculate the selected color. Now let's take all of this stuff again. Now we want to calculate the spectrum color. So all of the calculations are the same. I just need to come up here and grab this final selection of color, or the linear interpolation step. And so we're going to return the linear interpolation between the calculated colors. I'm going to get rid of these print statements now that we've already verified that it does what we think it does. So now we can instantiate one of these color blob spectrums. We give it the physical dimensions that we have, and now we can say, tell us which color is selected and tell us the current spectrum color. So let's go back up to our widget, and we're going to delete a lot of this stuff. And we can delete all this stuff. And what we're going to say is we're going to say final color blob spectrum. We're going to invoke the factory method, which is from physical dimensions. The size is renderbox.size, and the selectable colors are the selectable colors. We'll save that. Don't worry about the error. So now when we invoke this callback that's provided to us with the spectrum color and the selected color, we actually get them from our new object. So we will say color blob spectrum. We will say calculate spectrum color, and we'll pass in, what did we call it here? Touch position dx. And then color blob spectrum calculates selected color touch position dx. And so now our widget code has been reduced to 3 steps. We retrieve the render box, we create the logical representation for the color blob spectrum, and then we invoke the callback with the selected color and the spectrum color. Let's save that. Let's do a hot restart just to make sure everything's cool. And sure enough, everything appears to work as expected. So that's one refactor that I would personally do on a project like this. Let's see if there are some other things we can kind of clean up here. One thing I'm seeing is this invocation of the callback. The truth is we shouldn't spend any time calculating anything if this callback doesn't exist. No point in doing work if no callback is provided. So we'll just return, which allows us to then remove this if statement, and we can just automatically invoke that callback. Let's see if there's anything else. Another thing is these selectable colors. So right here, this selectable colors that we passed in, this is that global list again. And it's okay to have a global list, but we really want to push that as high up in the tree as we can. It would make sense that a color picker would receive a list of selectable colors, not reference the global value. So let's declare a final list of selectable colors. And let's take that into the constructor. And then down here, where we reference it, we will say widget.selectableColors. And then right here, we will say widget.selectableColors. And now, of course, we need to actually pass that in. And we'll still pass in the global value. That's fine. But we've moved it up out of the color picker. Now it's the application, the beginning of the application that decides to reference the global list instead of us reaching up to global information from within our widget. Also, this onColorSelected, like I mentioned before, I actually already had a function or a method to respond to that. So let's just get rid of this inline implementation and say onColorSelected. This simplifies our widget tree a little bit, so it's easier to read what's going on. And also something that you're going to have to keep in mind as a widget when you're developing widgets is that this onColorSelected callback could change at any time. I guess that probably doesn't matter because we're invoking it as the user interacts with it, so it should always be up to date. However, one thing that could change of relevance to us is that right now when we use the given selectable colors in our color spectrum, we're creating this map or we're mapping to those colors every single time we build the widget or rebuild this widget, and that's unnecessary. We can do that only when needed. And so in this state object at the top, let's come up here and let's have a list of color, which we will call colors. And then in init state, here, let's go ahead and let's compute that list. So I'll cut this out and we'll just say use the colors in our list. And we will say that colors equals that map. And that works for when we first initialize the widget, but it's also possible that the widget changes in the didUpdateWidget method. So here we can say if widget.selectableColors is not equal to old widget.selectableColors, then let's recompute our color list. Let's do a hot restart. Okay, so I think we're still good. So now when the widget is first created, we go ahead and map the colors to a list. And that way, the widget tree can rebuild. But if this widget doesn't change its colors, we don't waste any time recomputing that list of colors. And so now our widget tree for our entire color picker is pretty straightforward. It's one gesture detector that reacts to 2 events and our color spectrum, which just receives a list of colors. So I think for the most part, we've done a pretty good job here of cleaning up the color selection code. And that means that step 3, our final step, is to go ahead and shape our spectrum something like what we see here in the spec. So we'll do that in step 3. Our third and final step is to go ahead and stencil out the desired shape for this spectrum that we've created. So in our color picker, let's go down to the widget tree within our color picker. We have a gesture detector and a color spectrum. The gesture detector has no visual impact, so we don't really need to worry about it for this. The color spectrum, what we'd like to do is clip it. We want to clip it along a path that looks like what the spec shows us. So let's surround the color spectrum with a widget, which is clip path. And it wants a clipper. And so we'll give it, I don't know, a blob spectrum clipper, which we haven't defined yet, but we need to. So that clipper needs to return a path that gives us the shape that we want. So blob spectrum clipper extends custom clipper. It returns a path. Override the 2 methods. Should reclip. For now, will always return true. And then up here in get clip is where we need to return the path that gives us the shape that we want. Now, one parameter that I know we want to take in for sure is line thickness. In the spec, we have a horizontal line that goes from left to right. We can make it variable size by bringing it in as a property. And we can show how this clipping works by going ahead and actually drawing that line, and then we'll take it from there. So let's start off by creating a new path, and then let's invoke a method which is add horizontal line. And we'll take in the path that we need to work with, and we will take in available space, and we will take in line thickness. Now, given that information, we can take the incoming path and we can add a rectangle, because a line with thickness is just a rectangle. So we can say rectangle from left top width height. The left is 0. The top is available space dot height divide, we can shorten what I was about to say by taking the height, subtracting line thickness, and then dividing that all by 2. The width is the total available width, and the height is the line thickness. So add horizontal line. So in the vertical center, we go all the way from left to right with a rectangle that is as thick as our desired line thickness. So up here in add horizontal line, we'll pass in the path, we'll pass in the size, which is the available space, and we'll pass in the line thickness. And then at the end of this method, we will return that path. And then up here where we actually declare the use of the blob spectrum clicker, we'll go ahead with a line thickness of 10. And let's see what this does for us. All right, you see that? Now we've reduced the size of our spectrum to just that horizontal line. And that line is the part that goes all the way from the left to the right through all the blobs, which means that our next step is to draw the blobs. Now, to cut out the blobs, we don't actually care about the colors. All we care about is the number of selectable colors. So we will declare a color count, and we will require that in our clipper constructor. Up here, our color count is colors.length. Now, given that information, we have to figure out where each one of those blobs sits, and we have to add it to our path. So we can say for I is 0, I is less than color count. So this is each blob. And then we know that somehow we want to add blob to the path. Now, to be able to cut out the blobs, we need to actually know what their size is. And so up here at the top, we can calculate that the blob diameter is the height of the available space, because that's the same rule that we decided everywhere else in our implementation. Now, given the blob diameter, and then given the total available width, we can figure out where every blob goes. So if we haven't defined this method yet, but this method, conceptually, it knows how to draw a blob. So we give it the path, we give it the, let's say, the available width, we give it the blob diameter, and we give it the index of the blob that we're currently trying to draw. I think that's enough information to accomplish our goals. Let's find out. Okay, so we want to take this path and we want to add an oval, and it's an oval as defined by a rectangle. So we'll say rectangle from circle, which sure feels like a lot of indirection here, from oval to rectangle to circle. And that wants a center and it wants a radius. Well, the radius is easy. That's just the blob diameter divided by 2. The center is an offset, so it wants an X and a Y value. So the Y value is always going to be halfway between the top and bottom of the available space. Now, so I guess really, instead of taking an available width, we're going to want both pieces of information. So let's take in available space. So the vertical position, the vertical center of a blob is going to be available space height divided by 2. But we still need the X position. So what is the X position? That's going to be based on not only the diameter of the blob and the index, but actually it's also going to be based on the separator space. So let's calculate that as well. So the separator space, which we calculated earlier, was the available width minus, well, now I'm seeing it's minus the total number of blobs, which we didn't pass in. So let's actually calculate this globally instead of per blob. Let's come back up here. Here's where we have the blob diameter. Let's go ahead and say available width minus color count times blob diameter. That's the total available space between blobs. And then we divide by color count minus 1. And this is the same math we did earlier, so it shouldn't be anything new. That's the separator space. Let's pass that in to our invocation of add blob. So path, size, blob diameter, separator space. Let's add that to our declaration. So then the X position, if you think about, so let's just really quickly run through this. The X position of the first blob is radius distance from the left. The X position of the second blob is diameter plus space plus radius. Then the third one is 2 diameters and 2 spaces and a radius. So following that pattern, we can take, so blob radius is blob diameter divided by 2, which means we can now replace our bottom value with blob radius directly. And then the calculation we just described was blob radius plus index times blob diameter plus separator space, which apparently I misspelled. So let's spell that right. Okay. So we're going to add an oval, which is centered at the math we just did. That's the X position. It's vertically centered in the available space, and it uses the radius that it's given. So that should add every blob. And there are the blobs. Still respects the selection of different colors. And it's looking pretty darn close to what we have here. Now, this has taken longer than I thought it would, so I think we're going to end it here. We did go through these 3 steps. We rendered a color spectrum, we calculated which color is selected, we cleaned up the code, and then we created most of the shape that we want. You should at least understand how to get to the final goal. But this has taken a while to do, longer than I was expecting. I'll try to keep future workshops shorter. What I'll do is this. I'll go ahead and I'll create another video that shows how to get those curves in there, get curves in the spectrum so that the blobs curve into the line and out of the line. I'll also add a video that shows how to build this overall user interface. It won't be functional, like the counter won't work, the dropdown won't work, but I'll show you how I got all of this laid out before the workshop even started. So if you're interested in learning all that extra stuff, you can go to my website, superdeclarative.com. I'll put the videos on there in an extended widget workshop, and it'll be available to you. It'll be available to you for about the price of a cup of coffee. So we're going to call it right there. This is how you build a blob color picker, and I'll see you in the next widget workshop.